Alright guys, in this video we'll be continuing looking at ellipses. What we're going to be looking for today is looking at something called the focus or foci of the ellipse. And the foci are going to be these points located within the ellipse. Now, a couple of things that we're going to need to know is those 2 points that we're looking for will always be on our major axis of symmetry. So that's this one right here. It will always be on the longer axis. Again, these are the 2 points that we're going to need to find. And in order to find those 2 points, what we're going to need to do is find the distance from the center, which is right here, to these points over here. And we call that the focal length. And we use the letter C to represent that length. This distance over here would end up being the same distance. That is also the focal length, which again we're calling C. So what we're going to need to do to find these 2 points is first know the focal length. And in order to find the focal length, we're going to use this formula here. C equals the square root of the absolute value of a squared minus b squared. So this is the formula we'll be using in order to find this distance from the center to these points called the focus. Alright, so now let's go ahead and take a look at examples and how we find these 2 points here. Alright, so let's take a look at our first example. Here we have an ellipse, and we're going to be finding these 2 points called the foci. We have one here, and we also have a point over here somewhere in this area. So the first thing we're going to need to do to find these 2 points is find the distance from the center, which is right here, to these points over here. And again, we're calling that the focal length. So in order to find that length, we're going to use this formula, C equals the square root of the absolute value of a squared minus b squared. So the first thing I need to do is find out what a squared is. Now remember, a is the horizontal distance, the distance from the center to these points called the vertices. So if I'm looking from here all the way to here, we're looking at a distance of 1, 2, 3, 4, 5, 6. So the distance from the center to this point over here is a horizontal distance of 6, but we need it squared. So 6 squared would be 36 minus b squared. Now we need the vertical distance. The vertical distance is the distance from the center to this point up here, and that's a distance of 2. But I need to square that 2. So 2 squared would be a 4. So what we have here is C equals the square root of absolute value of 36 minus 4. So if I enter this into my calculator, the 36 minus 4 would be 32, and the absolute value of 32 is 32. And if I take the square root of 32, I get approximately 5.7. So in other words, the distance, let me go ahead and write that here. We now know that the distance here is 5.7. That's our focal length, the distance from the center to these points called the foci. Now we're looking for actual points here, coordinates. So we're going to find those 2 coordinates. Now keep in mind that our center right now is at 0, 0. And that's our center. We're talking about this point right here. That's, oops, let's fix that. What we're looking for is this point right here. What is that ordered pair? Well, remember, we moved a distance of 5.7 units over. So now my x value is 5.7. My y value is 0. But I also have another foci right over here. And remember, this distance is the same as what we found earlier. It's 5.7. But this time I'm going to the left here. So if I'm at 0 right now and I go to the left 5.7 units, I'm now at negative 5.70. So these 2 points are what we call the foci. That's this point here and this point over here. Alright, let's take a look at another example. Again, what we're looking for are these 2 points called the foci. Keep in mind that these 2 points that we're looking for will always be on the major axis, and this right here is the major axis. So the 2 points that we're looking for are somewhere in this general area. I don't know exactly where they're at, but I know they're somewhere in that general area. So what we're going to do is we're going to find those 2 points. And in order to find those 2 points, we're going to need to find something called the focal length, the distance from the center to this point over here. And again, we're calling that C. This distance over here is going to be exactly the same distance. It's also C. So the first thing we're going to do is find the focal length. And this little formula over here is what we're going to use to find that focal length. So the first thing I'm going to need to do is find A squared. Now I know what A is. A is our horizontal distance. It's our distance from the center to this point over here. So we're talking a distance of 1, 2, 3, 4, 5. So we got a distance of 5 units. But if I square the 5, 5 squared would be a 25. Now what I'm going to need to do is find my vertical distance. So let's go ahead and find the vertical distance, the distance from the center up to this point here. And that's a distance of 3. But if I square the 3, that 3 becomes a 9. Alright, so if I subtract 25 minus 9, 25 minus 9 would be 16. The absolute value of 16 is 16. And if I take the square root of 16, C equals 4. So in other words, this distance here from the center to these 2 points is 4 units. So that's a distance of 4 units, and that's a distance of 4 units. Now that we know that, now we can find the 2 points called the foci. Now keep in mind that right now we're looking at this point, the center, and right now the center is located at the ordered pair 1, 2. And what we're doing is we're changing the x value. What we're doing is we're moving over 4 units to the right, which is changing the x value by 4. So if I add 1 plus the 4, I now have the ordered pair 5, 2. So this is going to be one of my foci. Now I need to find this one over here. Once again, we have a center of 1, 2. What I'm doing is moving to the left 4 units. So this time what I'm going to do is change the x value, but I'm going to change it by subtracting 4 because I'm moving 4 to the left. So if I do 1 minus 4, 1 minus 4 now puts me at negative 3. So the 2 points called the foci are located at the order pairs 5, 2 and negative 3, positive 2. Again, these are 2 foci. Alright, let's take a look at another example. What we're doing is we're looking for the foci. Now keep in mind I did tell you that the foci are always going to be located on the major axis of symmetry. This time the major axis runs vertically, so it runs like this here, which means the 2 points that we're looking for are going to be located somewhere in this general area and somewhere in this general area, somewhere around there. So let's go ahead and find out what these 2 points are. And in order to do that, the first thing we're going to need to do is find the focal length, the distance from the center, which is right here, to this point over here. So we're looking for this distance. We're calling that C, which is the same distance that we have right over here. That's also C. So to find that distance, we're going to have to use this formula. C equals the square root of absolute value of A squared minus B squared. So let's go ahead and start by finding A squared. A is the horizontal distance. It's the distance from the center to this point over here. Notice how that's a distance of 3. But if I square that 3, 3 squared is 9. Minus the vertical distance squared. So again, vertical distance is the distance from the center up to this point here. And that's a distance of 1, 2, 3, 4, 5. But if I square that 5, it becomes a 25. So what I need to do is figure out what is the square root of the absolute value of 9 minus 25. Well, I know that 9 minus 25 is negative 16. But if I take the absolute value of negative 16, I get a positive 16. And if I take the square root of 16, I get 4. which means my focal length, or these two distances right here, are 4 units. That's 4 units, and that's 4 units. So now that I know that distance, I can continue in order to find my foci, these 2 points. Now, keep in mind, the center of this ellipse right now is at 0, 0. Now, if I'm looking for these 2 points, let me go ahead and get rid of some of this stuff so we can look here. Alright, so we know that the center is at 0, 0. So what's going to happen here is, since I'm looking for these 2 points, what's going to change is not the x value, but the y value. The x is still 0. It's the y value that's changed. It's changed by a distance of 4 units. So if I take 0 plus 4, I end up with 4, which means that one of my foci is at 0, 4. Now I'm going to find this one over here. Remember, it's the y value that's changing. The x value is still 0. What we said was that this distance right here was 4 units. So if I go down 4, 0 minus 4 is negative 4. So the other foci is 0, negative 4. So these are my 2 foci for this ellipse. Okay, let's go ahead and take a look at one more example. Remember, what we're looking for are these 2 points called the foci, and they're always located on the major axis of symmetry. So here's our major axis. So the 2 points that we're looking for are going to be located somewhere in this general area. Again, I'm not sure exactly where they're at, but I know they're somewhere in this general area. And what we're going to need to do is find these 2 points is find something called the focal length, the distance from the center to these 2 points. Again, we call that C. This distance is also the focal length. We're calling it C. Alright, so to find C, or the focal length, we're going to have to use this formula: C equals the square root of the absolute value of a squared minus b squared. So the first thing I'm going to do is locate my A, or my horizontal distance, the distance from the center to this point over here, which is 1 unit, and 1 squared is 1. B is our vertical distance, the distance from the center of the ellipse up to the top, and that's a distance of 1, 2, 3, 4 units. But if I square the 4, that becomes 16. So now what I'm going to do is subtract 1 minus 16, and 1 minus 16 is a negative 15. But since I'm taking the absolute value of that, the absolute value of a negative 15 is a positive 15. And if I take the square root of 15, that's approximately 3.8. So roughly 3.8 is the square root of 15. So now I know the distance, or the focal length, is now 3.8. So this distance is 3.8, and this distance here is 3.8. So now what I'm going to do is use that in order to find my 2 foci. Now let's be careful here, because this is our center, and that center is located at negative 4, positive 1. And what I'm looking for is this point right here. Now what we should notice is that the x value is going to stay the same. Negative 4 is still the x value for that point. The y value is different. What we've done is we moved the y value up 3.8 units. So what I'm going to do is take this 1 and add to that 3.8. That's our focal length. So if you add 1 plus 3.8, obviously you get a 4.8. So this point here is located at negative 4, 4.8. That's one of our foci. Now let's come over and find this one here. Same idea. X value is going to stay the same. It's still negative 4. The y value is now different. Remember, we started with a y value of 1. That was the center. But this time what we're doing is we're moving down 3.8. So if I have 1 and I take away 3.8, now I'm at negative 2.8. So my other foci is located at negative 4, negative 2.8. So these are my 2 foci for this ellipse. So just keep in mind, guys, in order to find these 2 points, you do have to consider where the center of this ellipse is. So keep that in mind.